Hello, my dear students. Very good morning to all. Hope you're all doing good. Thank you so much for the patient listening and wonderful response you are giving for the classes. And the great welcome you have given for the videos was so beautiful. So, with this happiness, today we are going to see about treatment of boiler feed water. In the earlier class, we have discussed that impurities like hardness, alkalinity, and dissolved gases and other dissolved salts produces huge trouble to the boiler. So it is necessary to treat the water which is to be fed into the boiler. So we are going to discuss about how boiler feed waters are treated and what are the available methods. Now we are going to see about the softening or conditioning of hard water. We all know that hardness producing salts present in the water creates scales and sludges which tremendously reduces the efficiency of boiler. So hence we are in need to remove the hardness or hardness producing salts from the hard water. So the process of removing hardness or hardness producing dissolved calcium and magnesium salts from hard water is called softening or conditioning of water. We all know that hard water is nothing but water containing dissolved calcium and magnesium salts, whereas soft water is the water which is free from dissolved calcium and magnesium salts. So hence, this process of converting hard water to soft water is called softening or conditioning. So we can soften the water by two types of treatment, that is external treatment or external conditioning, or internal treatment or internal conditioning. Now we are going to see what is external treatment or external conditioning. So this is nothing but treating or softening water before feeding into the boiler. That is, we are going to treat the water in two ways. So treating the water outside the boiler and then feeding into the boiler, or treating the water inside the boiler itself. So external treatment is concerned about treating or softening the water before feeding into the boiler. That is, we are treating the water outside the boiler and the purified water or the soft water is fed into the boiler. Then comes our internal treatment or internal conditioning. So here the water is treated or softened in the boiler itself. Why we are treating the boiler water in the boiler itself? Because in external treatment, some of the hardness producing salts are not removed completely in some cases. So in that cases, to remove that leftover hardness producing salts, we are treating that water in the boiler. So simply external treatment, we are purifying the water outside the boiler. So in internal treatment, we are treating the water inside the boiler to remove the leftover hardness producing salts. So these are the two types of treatments or conditioning methods available to treat water. So in that, we are going to see external treatment or external conditioning methods. So that is treating the water outside the boiler and then taking in the boiler for the production of steam. So there are so many methods available. We are going to discuss about two important methods, that is ion exchange or demineralization process. It is also known as deionization process, and the second one is zeolite or permutate process. So we are going to discuss in detail about these two processes. Today we are going to discuss about ion exchange or demineralization process, what it is and what are the process and what are the advantages, disadvantages, everything we are going to discuss. So from the word itself, it is clear that demineralization means removing all the minerals present in the water. Deionization also means that removal of all ions present in water. So in this method, we are not simply removing the hardness producing ions, and also we are removing almost all the ions present in water. So hence we are saying this process as demineralization process. So that is removal of all ions or all minerals from water. Now a question arises, an interesting question. Demineralized water is soft water, whereas soft water is not demineralized water. Why? So this is a common doubt arises, and yes, as you guessed, demineralized water is soft water. Yes, because in demineralized water there is no ions, including calcium and magnesium ions, which means that demineralized water we can say that as soft water. But in soft water there is no calcium and magnesium ions dissolved, but some other ions will be present. So we cannot say that as demineralized water. So we can say demineralized water as soft water because it contains no ions. We cannot say soft water as demineralized water because soft water contains ions other than calcium and magnesium. So this is a common question arises in every mind. So that's why we have discussed it here. And now we are going to discuss about the most beautiful resins, the ion exchange resins. So again, the word describes everything. So resins are nothing but polymers. Ions, we know that cations and anions. Exchange is nothing but giving a particular ion and in turn returning some other ions. So taking and giving like that. So ion exchange resins are the resins which are capable of exchanging their ions with the hardness producing or harmful ions of the water. So here you can see they are actually available in the market in bead like structures. They are crushed and used in the ion exchange columns. So they are capable of exchanging. So water containing so many impurities, and in that impurities there are so many cations and anions are present. So those cations are exchanged by the ion exchange resins. Now we are going to discuss about these ion exchange resins in detail. So here are some examples for ion exchange resins. So here you can see both the types of resins like cation exchange resin and anion exchange resin. Now there are two types of ion exchange resins. The first one is cation exchange resin and the second one is anion exchange resin. So cation exchange resins are resins, they are capable of exchanging harmful cations present in water like calcium 2 plus, magnesium 2 plus, Na plus, K plus, Mg2 plus like that. What are all the cations present in water? They are harmful to the boiler. So hence we are mentioning here that as harmful cations. So these cation exchange resins exchange harmful cations present in water with its harmless H plus ions, which means that cation exchange resin contains H plus ions and it gives the H plus ions to water and takes up the cations of water. So the cation exchange resins usually contains the following functional groups like carboxylic acid, sulfonic acid, phenol groups, etc. And anion exchange resins are resins which are capable of exchanging harmful anions present in water, which means that it gives OH minus ion to the water and takes up all other anions present in water. Say example Cl minus, SO4 2 minus, HCO3 minus, like that. So anion exchange resins, they will contain functional groups like ROH, RNH2, quaternary ammonium salts, etc. But usually it is convenient to take up anion exchange resin containing OH minus ions. Hence, the byproduct will be very safe. Otherwise, we can get some other products which have to be removed continuously. So this is about ion exchange resins. Now we are going to discuss about a demineralization plant and how it looks like. So here is in the first picture, animated picture, you can see how a demineralized or a demineralization plant looks like. In the second image, you can see the diagrammatic representation of a typical demineralization plant. So in that you can see the raw water or impure water is passed through cation exchange resin or cation exchanger first. Then water free from cations is passed through anion exchanger or anion exchange resin. So this is the flow of the water, and please note that there are two different containers. One is attached to cation exchange resin containing acid, and the another one is attached to anion exchange resin containing alkali. So keep it in mind. So now we are going to discuss about the process or steps involved during the ion exchange process. So at cation exchanger, the water is first passed through cation exchanger always. You can see the cations like Fe3 plus, Al3 plus, calcium, magnesium are getting removed, and the water is now free from cations and only containing the anions listed. Are you clear? Fine. Now you can see how this is taking place. At cation exchanger, the H plus ions present in the ion exchange resin is given to the water, and the ion exchange resin takes up calcium 2 plus, magnesium 2 plus, Na plus, K plus, etc. So this is a simple adsorption process and also an exchange process. So this is how all the cations are removed from the water and H plus is given to the water. So here you can see the H plus, that is the red color balls are going to the water, and blue color, green color cations from water is getting adsorbed to the ion exchange resin, that is cation exchanger resin. Now we are going to see about the things happening in anion exchange resin. The water free from cations are now passed through anion exchanger. So while passing through anion exchange resin, wait for a moment please. Yes, now. So you can see that the water free from cations is passed. Now the anions are getting removed, and finally H plus from cation exchange resin and OH minus from anion exchange resin combine together and forms water, which means that all the cations and the anions are removed from the water. Now you can see the same things, that is the exchange happening in ion exchange, that is anion exchange resin and water. Here the OH minus ions from the resin is going to the water, and all other anions like Cl minus, SO4 2 minus are getting adsorbed over the anion exchange resin surface. So this is how the entire process takes place. Now we are going to discuss about the reactions which is taking place in the anion and cation exchange resin. So first in the cation exchange resin, the cations are removed and the water free from cations are passed through the anion exchange resin. Now the anions are getting removed by the anion exchange resin. Finally what we will be getting is simply demineralized water without any ions. Now for your convenience I am going to write the equation. We are going to see about the reactions taking place at anion exchanger and cation exchanger. Cation exchanger is nothing but the cation exchange resin filled column. So where we are going to represent the cation exchange resin as RH or RH2. It is our convenience. So now we are going to write any salt present in the water. So we are going to take two salts, for example, one harness producing salt and another some other salt. For example, here the magnesium is taken up by the cation exchange resin and the water is now free from cations. Similarly, the potassium is taken up by the cation exchange resin and the water is now free from cations. So this is how cation exchange resin takes up the cations present in the water. Now we are going to pass the cation free water into anion exchanger. We are going to represent the anion exchange resin as ROH twice or ROH. It is our convenience. Now the water free from cation is passed and the anion exchange resin takes up the anion from the water. Now, so H and OH combines to form water. So this is how both cations and anions are removed from the water by ion exchange resins. Now we are going to see about the regeneration process. What it is actually. So we are continuously passing water and removing cations and anions from the water, making demineralized water. So when the process continues like this, the resin loses its nature at one time, which means that it loses its own cations and anions and it getting occupied by the cations and anions of water. So then it loses its ability to exchange ions, which means that the resin becomes exhausted. Now we have to regenerate the exhausted resin for further use. So how regeneration is going to take place? Now we are going to discuss that. So a regenerated resin or fresh resin contains Na plus or H plus in it. So during the exchange process, the ions like calcium, magnesium, potassium, sodium are getting occupied in the sites and the resin loses its ability. Now we have to add either Na plus or H plus to make the resin function again. So here you can see the image where the H plus ions are getting attached to the resin again and all other cations present in the resin is removed. See, H plus are getting attached to the resin again and all other harmful cations in the resin are removed. So now we are going to write the equation of regeneration. That is how regeneration takes place. In simple, we are going to make the resins active by regeneration. So for regenerating cation exchange resin, we are going to use dilute hydrochloric acid. So here the resin containing the exchanged cations are regenerated to its original form, that is RH2 plus CaCl2, 2HCl. Similarly, you can see that any cation exchanged resin is regenerated in this way. So here now you can see the resins are getting regenerated again. So these are resins which are contaminated or occupied by harmful cations of water. So by adding dilute hydrochloric acid, we have regenerated the cation exchange resin in its original form. Now to regenerate the anion exchange resin, we are going to use low concentration of NaOH or dilute NaOH, where the resins exchanged the anions are getting regenerated readily to form active anion exchange resin. Fine? Yes. So the cation exchange resin is regenerated here and the anion exchange resin is regenerated here. Now the resin is ready for usage. There are so many advantages and disadvantages in the demineralization or ion exchange process. The best part of this process is we can make the water up to 2 ppm hardness. That is, we can reduce the hardness up to 2 ppm and we can easily treat water with high acidity or alkalinity. The disadvantage is we cannot use turbid water as it disturbs the ion exchange process, and also we cannot use water containing iron and manganese because these ions once attached to the resin, then the resin cannot be regenerated. That is the biggest problem. Hence we cannot use water containing iron and manganese. and the another process is it is quite costly. So with this, we are going to conclude this session. Thank you so much for the wonderful listening. If you have any doubts, please feel free to ask me. Thank you so much. Have a nice day.